Hello, everyone. Thank you for joining today's Geospatial Fellows webinar. I'm Xiao Wang from the University of Illinois at Urbana-Champaign, serving as the director for the CyberGS Center for Advanced Digital and Spatial Studies that has organized this Geospatial Fellows webinar series in partnerships with AAG, UCGS, OGC, and NORC at the University of Chicago. We would like to acknowledge the support of the National Science Foundation for this community event. And I'd like to extend my many thanks to several colleagues, in particular, Dr. Colleen Doney and Julaiti at AAG, and Dr. Anand Padmanabhan and Becky Vardawali at the UIUC CyberGS Center for their wonderful work on helping run this webinar series smoothly. Now it's my great honor and pleasure to introduce today's speaker, Dr. Ningchuan Xiao, who's a professor of geography at the Ohio State University. Dr. Xiao is an expert of geographic information science and spatial analysis. His research has covered broad research topics such as mapping and data visualization, spatial optimization and decision support systems, spatial and temporal modeling, and environmental modeling. His lecture today is titled Towards Transparent and Ethical Human Mobility Data. Dr. Xiao's lecture will be discussed by Dr. Douglas Richardson at Harvard University. Dr. Richardson is very well known for his leadership, serving as the executive director for AAG from 2003 to 2019. Thanks to his great vision and leadership and tremendous efforts, AAG has greatly expanded its membership and international footprint, developed dynamic and wide-ranging new research initiatives, and built strong academic publishing and financial foundations. Dr. Richardson is an expert of real-time mapping, spatial data acquisition and analysis. His recent research has focused on the integration of spatial concept data and analysis in the social sciences and humanities domains. Without further ado, let's welcome Dr. Ningchuan Xiao to give his lecture. I'm going to pass the Zoom control to Ningchuan. Please take it away. Thank you. Ningchuan, you are still muted.
Yep, thank you, Xiaowen, and thanks to everybody for coming today. We will talk about some issues about human mobility data. I will have a co-presenter, Yuelin from Ohio State, and I will introduce her when her time is up. Recently, recent years, we have seen a new wave of data, and this new wave of data is different from what we have seen before, such as census data, such as remote sensing, because we are constantly being watched, right? So being sort of observed, if you will. So there are a variety of ways our movements, our locations can be recorded. And then there are a slew of different companies. They utilize these sources, and they package the data in different ways, and then process the data so that they can sell to different people, i.e. researchers, marketing people, and advertisement companies, and so on. So this new data, because they have human locations, they have human subjects in there, they raise a lot of issues recently, and today we're going to take a look at what are the issues, how we can examine the consequences of using this data, and what are the problems of this data. So let's first take a look at the dark side of data. So the problems with the data is not new. It has been with us for many years. Now this is a map made by the Nazis before the U.S. entered the Second World War officially, and this is a map that identifies was used to help the Nazis to allocate their money to the states so that they can persuade the US population to be on their side. Of course, they want to identify who are their people. And at some place on this map, it says classified. So this map is, it's real, and it's really scary if you think about that, right? So the census data is as innocent as it can be, right? And so it's, quote unquote, protected by different, legislations, and by all kinds of ways. So the census does have some kind of description about what they are going to use the data for, and how the data will be protected. Of course, we all know that data like this can be only protected to a limit. And during the Second World War, the exact address information of every individual family for the Japanese Americans were used to round them up and send them to incarceration camps around the U.S. So this is a cover from George Tech, who played a leading role in Star Trek. So he spent his childhood in one of those camps. And also recently, we know that the cell phone location data have been used for the law enforcement to round up illegal immigrants, and of course they are able to access to that type of data. So apparently there are a lot of issues that are around the data, how the data are produced, what are the algorithms that produce them, and so on. So in today, we will be talking about the dark side, which we have already seen. So they are a little bit extreme to some sense that some data are not as much harmful as they seem to be in that way. But then still we need to talk about them. So we will talk about two specific sort of big mobility data sets. And then from there, we're going to look at the conceptual, maybe sort of theoretical underpinnings of how data can be examined from this ethical lenses. And then we will talk about the ethics of data and the algorithm. And then we will talk about a case study. And from that case study, we will focus on a specific traffic camera data set, data source. And then from there, we will lead to the discussion of data transparency and algorithm transparency. So that's the plan. Now, on the two data sets, I need to get this out of my screen. I can't. That's fine. So the first data set is the call detailed records. So every time we make a phone call, we send a text message. Our phone carriers will record that. It does not record the content, but it will record the event. So the event would include the time, the location, and the phone numbers. Who sent it, who received it. And this type of records are relatively easy to obtain, especially by the law enforcement, because they are not protected by the First Amendment. So apparently it has been used by a lot of cases, and a few really high-profile research projects are done based on that data. They are listed here. But apparently, when we sign up a mobile phone contract, we don't even know this, right? So we don't know who will get our phone call information and how that one will be used. And also, sometimes the location information is available there, but there is no way that that type of location data is accurate. Now, this figure comes from the New Yorker magazine, and there was an interesting article there to describe how this specific CDR reports have been used to wrongly identify somebody who didn't commit the murder, but she served some jail time. So that's highly controversial in that sense. And then we don't really know the potential errors of the data, the biases of data, and so on. So those problems are obvious, right? It's not like they are really hard to understand, but they are there. So, and then the second type of data is what is the street light data. So make sure you don't get confused by the name, because this is not about street lights. Okay, so it's a company's name. It actually uses a variety of location mobility data to produce their own data. So the nice thing about this particular data set is you can specify, a set of origins and destinations, and the streetlight can produce this OD matrix. So this origin destination flow matrix for you. So that is extremely useful for research, for advertisement, for marketing. But then again, when we use our mobile phone to watch ESPN, for example, right? To go to ESPN's app. So there are a lot of advertisements there. So those advertisements actually track us. So do we know that? Do we even know that that type of information gets into this company, and then they sort of package that, chop them into pieces, and then sell them to different users. So that type of huge unknown is really important for us. And we also don't know what kind of algorithms, right? So do they use gravity-based spatial interaction model to get the OD matrix? We don't know, and they didn't tell us. They didn't tell anybody. So then even though they claim this data is already better than most of the other data vendors can provide, but then again, those issues will cast doubt about any results or any kind of research you want to use. Maybe for marketing, they don't really care that much, but as researchers, we probably should. So apparently there's an ethical crisis in mobility data, or just in data in general, right? Because we have those participants, we contribute our data, we contribute our our part, but we didn't know. So, and we probably don't even want to, right? So, so for people who use iPhone, the latest iOS actually requires all the apps that track people to get consent, right? So we are able to say no to to being tracked. Okay, say no to Facebook, and that's what it is. Now, guess how many people said yes, right? How many people wanted to opt in? Only about 4 to 3% in the first 3 weeks after the new release of the iOS. So that doesn't sound good news for a lot of people, but that's how unwilling we are, how unwilling the customers or the users or the general public are in terms of this particular, in the ecosystem of the data. Now, then on top of that, you have this opaque algorithms, right? The algorithms, we don't really know what is going on. And sometimes, as you will see later, even those data vendors, they don't even know the mechanisms used inside the algorithms they use. And then, of course, there's a huge sort of unknown about what this data will be used by whom, for what purposes. So there is a lot of issues here, and let's see how we're going to unpack this problem. Now, to unpack this problem, we really want to trace how the data gets into what it is as a being in today's information ecosystem. Now, of course, data, all starts from somebody moving, right? So as you can see, my slides are normally, I wouldn't say perfectly, so well balanced, but this one is not. So I specifically put this slide to be asymmetrical. I want everybody to, take a look at this and understand how unbalanced the power is. So as the people who initiate our, movements, we don't really have any say about how this one will get into the end product here. So more than that, some sensors are watching us, observing us, and then that generates the raw data, not necessarily through a lot of processing, but maybe there are some processing there. But then definitely the algorithms are used to create the final data. So under every step, there are some people, right? So data agents and the users will use the algorithms and so on. And the data can also be used by algorithms to produce other things, other data or some other, conclusions about the problems and so on. So that's the process. And then almost every element, okay, a line, an arrow, a box, even a stick figure. This is a quasi UML diagram, as many of you might have already identified. So every element here, we will have questions about what is going on, what happens, and how can we understand it. So now to understand, to understand the ethical aspect of the data, there are quite a few different frameworks, different models that are proposed. But I would draw the my theoretical strength from the framework developed by Luciano Floridi at Oxford. So his model is called RPT model. So data can be used as a resource, right? So we use data to analyze something, and we also may produce data. And now we also might want to protect our data or protect the data because somebody else might hack it. So all those are the considerations. So let's take a look at how can we use that model to analyze mobility data specifically. So the mobility data, when we use that mobility data, sometimes we need to ask, are we using the best information, right? So there is a lot about accuracy here. Now, if we have any doubt about the accuracy of data, we probably should be really alarmed, right? So that's really the right question for us to ask. Then in addition to that, there are a lot of other things we might want to consider. Do we have enough data? Is more data better? What is the level of accuracy or what the level of privacy of the data we should use? It's not necessary we should use individual data for every application, but so we have to make such a decision. And that decision is really an ethical decision because whatever you decide, it will have some consequences. So is our data wrong, right? Is there any bias because of the source where it comes from, and so on. Now that's the mobility data as a source, and then you can when we create our own data. Now there are also other things we need to talk about, right? So when I say we, it's a generic way to say whoever produces the data. So it might be the companies. So you might ask, should we be even responsible for the use of the data? Well, if you ask a street light, literally they might just say no, right? Because there's always a disclaimer from the data you can get from them. Basically, that says they are not going to be responsible for how you use the data or for what are the damages that the use of data might have caused. So that is a huge issue for us for the mobility data to be really useful. Now, so as an ethical company, of course, you might need to carefully examine the outcome of the data and then make your good decisions. And there are a lot of other things we can ask as well, right? So each of them we can probably go to certain length to discuss. But let's move on to the other part, to the third aspect of data being targets. Now, even for the census data, there have been research talking about how we can use the census data to identify individuals, right? So the census data has gone through a lot of scrutiny to make sure that they don't reveal personal information, they don't violate privacy. So then the other data, of course, census data is relatively open, but the other data sets, they don't even we don't even know what's going on in the data. So there's a large so there's a lot of questions about those things. So we have to think about the data can be used by different people for different purposes, especially for sort of unauthorized purposes, even though they don't need authorization to use the data a lot of times. Now, what about algorithms? So algorithms are separate from data because we will see that the algorithms will have different ethical concerns. So they are different, but they are closely related. So when we talk about the algorithms, there are different ways we talk about them, right? So when I wrote my book, a few years ago, I immediately dived into the trap of mathematical definition, right? The mathematical aspect of algorithms. Because that's fundamentally exciting for sure, right? It's it's very interesting. It can have a lot of applications. So that really happens in a lot of definitions we can find. But but actually, since the very beginning of the computer science education, right, or computer science industry. Donald Cruz, for example, maybe the father of modern algorithms, maybe. So his definition has something, that is lost in a lot of ways, because he seems to say that we can get the algorithms to return what we want, right? So we can specify the output, and the algorithms, can get that to us. So there are people also talk about, the algorithms are computers. Okay, that's basically meaning the software or the algorithms are logically malleable. So you can hammer the algorithm to the shape you want. Basically, that's what it means, right? So that type of recognition of the problems of the algorithm has been picked up by a lot of people, right? Not necessarily just in the computer science community, but also by geographers, for example, Robert Kitchen, so who clearly identifies the social technical aspect of the algorithms. So we have to consider the algorithms in the social discourses, where how the algorithms are talked about. A lot of times people are not even talking about the mathematical aspect of algorithms. They're just talking about how algorithms are a part of being in our society, right? So it should share the responsibility of all, like us. So that's the important aspect. Now, if we look at the mobility data here, we will see, let's take a look at this mathematical and social constructs for the algorithms in the realm of mobility data, right? So we have probably learned from the previous research and from textbooks, maybe a lot of different algorithms, models, gravity models for spatial interaction, for example, is heavily used to produce OD matrices. And so what are the parameters of these models, right? So that's really the mathematical consideration. But we also have to think about other things. Now, I put this really exciting word of computational intensity. So I didn't mean just computation, right? So if you think about computational intensity, we are thinking about who can afford it, right? Who are able to afford the computing facilities that can be used to address these models that require a lot of computing power. Not necessarily everybody has that resource, and then not necessarily everybody has that much data to drive the the algorithms in order to get results. So apparently there is a reason why crypto mining is so popular in certain countries but not in other countries, right? So the computing really has the power struggle here, where the people who can afford can do more. And of course, then we rely on open source. But what about some other proprietary software or algorithms that can be more efficient, and we cannot afford them, right? So those are the issues that that algorithms we should consider. Now, to sort of shape our consideration of the ethical aspect of algorithms, there are again different models. So this model is again from another Oxford guy, Mattelstadt, and his colleagues developed this sort of framework or a map of ethical concerns regarding algorithms. So when the algorithms are used to produce knowledge, so that's then we would have some kind of epistemic concerns. So is knowledge conclusive, right? Are there any uncertainties in the knowledge or conclusions we got from the algorithm? Can we look at the algorithm and see, if we can understand the algorithm, how does it work, and so on. Now, if the algorithms are making decisions for us, then we, should we follow that, right? Should we follow? Are those decisions fair to other people? And then, in the long run, if we keep relying on the algorithms, would that shape our ability to make our own decisions? So that's another one. Now, this traceability basically means if the algorithm, causes some kind of damage, right? We need to find somebody to blame. Now, how can we find it? So are we able to trace back through the algorithm to find the parts that are, responsible for that type of damage? So this traceability may not be known. because may not be available because certainly because how the algorithms are packaged. Now also because we are using algorithms to produce our data, for example, now we should also have some informational concerns about the algorithms. So we shouldn't, if some data are better or perfect, what do they mean by that, right? So what kind of algorithms are used to produce that? And are the data biased or unfair to a certain group of people? Should we totally trust that data just because the vendors told us we should trust that? So those are the concerns. Now, sorry for coming back. So a lot of discussions here is really about, are we able to analyze, or are we able to examine the details of the algorithm, right? So that really speaks to the transparency issue. And we plan to use this case study to highlight some of the transparency issues of how a transparent research project can be done. And we are going to use the traffic cameras around central Ohio to demonstrate this case study. Now, I want to make sure that we don't get to the wrong idea that these cameras are not used to recognize people's faces or your license plates, okay? So they are purely installed there to monitor the traffic. So that's what, it's the transportation systems. So our ideas here is, in order to use this data, which has tremendous potential to contribute to other mobility data sets, right? So, but the current vehicle detection models, they are not as accurate as some cases. So we are going to try to sort of examine how can we improve the accuracy and how can we use that to obtain more accurate traffic estimations. So for that purpose, I want to invite Yuelin to tell us more about this. And Yuelin is a PhD student at Ohio State. She has been working in this area, and this is her second year. Yuelin?
Yeah, can you hear me?
Yes.
Yeah. So, I want to first introduce the goal of this case study. So the case study is developed to design a transparent and reproducible algorithm that can be used to produce accurate road traffic metrics from the camera feeds. So road traffic metrics include traffic flow, speed, and density. They're important mobility data products, and they have been used in various areas, especially in COVID-19 research. The reason why we want to use traffic camera data to obtain the road traffic metrics is that these data are totally open. There are no restrictions to access, distribute, and create derivative works from the data. The openness of the data source is very important in order to have a transparent and reproducible algorithm for data production. So in this study, we use images from 70 cameras in Central Ohio to train and test a model for vehicle detection. Images from 6 cameras are used to test the effectiveness of our algorithm in the production of road traffic metrics. Next slide, please. So today, many vehicle detection models have been developed to extract the mobility information from these data. However, these models still have some limitations. Their accuracies vary significantly among different camera configurations and environments, especially for vehicles that appear to be very small on the images. So if we look at these 2 examples below, we'll find that vehicles close to the cameras generally have a higher level of detail, and they can be correctly detected by the models. But for the small size vehicles that are very far from the cameras, there is a lack of detailed vehicle features for the models to recognize the vehicles. So these vehicles tend to be missed by the models. The limitation of existing vehicle detection models can lead to significant errors in the estimation of road traffic metrics like traffic density. Next slide, please. To produce accurate road traffic metrics from the camera feeds, we focus on the regions and images where vehicles can be correctly detected. We call these areas the HAIR, which means high accuracy identification regions. We use a quad tree-based algorithm to identify the high accuracy regions in the images. In this process, we keep partitioning the images into quadrants until the vehicle detection accuracy of a quadrant reaches a threshold. The quadrants that do not reach the accuracy threshold will be further decomposed until the user-defined maximum level is reached. The quadrants at all levels of division with the detection accuracy higher than the threshold collectively form the hair. In this way, we can obtain the hair for a camera. Next slide, please. So here we present the overall workload to estimate the road traffic metrics using the high accuracy regions in the images. So first, we collect some images from the camera and label the vehicles. Then some vehicle detector is selected to detect the vehicles in these images. Based on these images, we try different combinations of parameter values to find a final hair that can consistently contain most correct detections. So these parameters include the maximum quad tree depth and the number of annotated images we use to identify the hair. Finally, the hair we obtain can be used to estimate road traffic metrics on new images. Next slide, please. A resampling procedure is used to determine the parameter values used to find the final hair. Derive the hair under some parameter setting and apply it to new images to calculate this error. The root mean square error over all the iterations is then calculated. As we can see from this figure, when we increase the number of images and the quad tree depths, the error converges. It means that at some point, even if we increase the number of annotated images and the maximum quad tree depths, the performance of this algorithm is not improved. Therefore, we will select the parameters where the model errors converge. Next slide, please. So we compare the vehicle detection accuracy within the hair and in the entire image extent. The results show that the accuracy of vehicle detection in the hair is 41% higher compared to that in the entire image. To demonstrate the effectiveness of this algorithm, we further applied to estimate the traffic density using the selected cameras. The traffic density here is calculated using the vehicle counts and the road lengths within the hair. We also calculate the errors of the traffic density estimates by comparing them to the ground truths. The results here show that using the hair, there is a 49% increase in accuracy for traffic density estimation. Next slide, please. So to make sure that this algorithm is shareable and reproducible, we are working on a Jupyter notebook that includes the code to implement this algorithm as well as the source data. Once this is done, it will be shared on the CyberGIS platform. Next slide, please. So as a summary, in this study, we developed a quad tree-based algorithm to identify the image subregions with high vehicle detection accuracies. We also designed a resampling approach to reduce the errors that introduced by using the hair. The results of our experiments show that the hair consistently exists in images with the same camera field of view. When the hair is applied to the road traffic metrics estimation, it is clear that it is useful to promote the accuracy of road traffic metrics derived from the camera images. The errors of using traffic density as the errors of these traffic density estimates can be useful to inform the data users of the quality of the data produced using our algorithm. And it also allows people to test the potential implications of using the data products. So by using an open data source, this algorithm is more feasible to fully share. It is more feasible to fully share the details of the entire data production process using this algorithm. And the production of the data can be more observable so that the uncertainties of the data products can be audited and the consequences of the data applications can be examined by a broader community. Yeah. So I think that's all.
Okay, thank you, Yue. So the idea here is if we are going to disclose how the algorithms are used and how the data are used to produce the final results. So we are talking about the transparency of the entire process. Of course, there are things that we cannot control, right? And then there are things we can. Now, the transparency shouldn't be considered as a naive term that says, your data is transparent, my data is not, right? So the transparency actually has different dimensions we should look at. So we are talking about the transparency of the source data and the transparency of, basically the understanding of the users of the data. And then who provide the financial support, right? Who are the partners? What kind of contractual facts that are important in the entire data transition process? And then of course the algorithm transparency, and then you got to know what's the legal and other policy issues related to the data, and of course their algorithms. Now, if we look further into a little bit of the algorithm transparency, so again, we're not taking transparency as a yes or no question. So apparently, there are algorithms that are impossible to see their source code, right? So we're talking about the algorithms because of the computation, because of the national security issues, and so on. So for this, algorithms, it is fine to be sealed in that sense, but that doesn't really mean we shouldn't understand the the algorithms. Now, since the last, a few years ago, Google started to allow their scientists and engineers to publish academic papers in conferences and journals, which is a huge step toward transparency. Now we're looking at Apple, right? Then of course, then there are algorithms that are just hard to understand, even though you look at the source code. I'm talking about the machine learning algorithms, especially neural networks. So even the developers of those neural networks do not have a crystal ball on how the algorithms work. So, but these are really the things that we should examine when it comes to the algorithms. Now, there are some tangible ways we can do with transparency. I'm not going to go through this list, but there are different tests that we can do to test the source, to test the consequences, just run some scenarios, and so on. So there are ways we can conduct ethical testing, and that doesn't necessarily have to be done by by the developers or anything. So that would be one of the things that we can do. Now I'm going to wrap up this this presentation part of the webinar by touching a few aspects of things. The first one is reproducible and replicable research, and the differences or the tension, if you will, between reproducible and replicable research, and the transparency is well documented. One of the Geospatial fellows, Peter Kidron, has written some papers about it. Now, also, there are ways that we can look at the requirements of privacy, right, protection at different levels throughout the entire process of data being used by different agencies, by different people, from the general public to the researchers to the developers, right? And then we can probably figure out a way. And Dr. Richardson wrote up this idea in 2015, and the idea is called a Geospatial Virtual Data Enclave. And then, by any means, when the companies or when the vendors say they seal the data, they shield the data from the third party because they want to protect privacy. That's probably not exactly what they want to protect, because by not allowing people to see into the data, how can you have oversight of the data and the algorithms, and how can we make informed applications of the data, which again would affect the privacy. And then the disclaimer about responsibility and liability is just totally not useful, and they may not be ethical, even though they might be legal. Now, also, so I would argue, I don't know if anybody has said this, but I would argue, data is not just only the new oil, it's also the new electricity that runs through the internet to power our analysis, power the business today, right? So if that metaphor works, then the data is really the utility. And if they are utility, they should be regulated. they cannot escape regulation simply because of the monopoly and the misuse of the data, right? Of course, there are a lot of issues that will come with that. Now, the European Union recently, passed the law and of what is called the General Data Protection Regulation, and so they require user consent when their data is involved. So that put a lot of companies into scrambling simply because of the consent. How do we get that? Millions of people, right? So it might be doable. So we will see about how that will happen in the US. And I think our education, our higher education, especially our geospatial curricula, to some way, we have made a big progress in terms of getting our students to understand professionalism. But I think we should move forward, a little bit more than just looking at ethical codes and those things. So the computer science community has been paying close attention to, to the limit of computing and those things. And that are part of, the grand challenges in computer science recently. And if we think about what we want our students to look like in the future, right? So we want them to have some deep understanding of the applications of data. And we also want them to have critical view of the data. Now, so I want to make it clear, right? So it's not just to understand the limitation, but also understand the power of the data and the power of the methods. And also they should have critical understanding of the computer systems. And then, of course, they should really have good understanding of people and the world. It's not just not like, they're just coding, right? They need to understand what the code actually does in the real world. Now, I'm having this here. I don't have time to go inside this. So this is really to think about, if you think about data as the security of the system. Now, in the industry, you have this blue team that tries to understand the cracks in the system. And you have the red team that tries to, break the system by penetrating, by looking at the cracks. Right? Then you have this purple team that tries to understand, how are we going to build more robust, more secure systems? So that mentality probably are going to be useful when we develop our curriculum for the future generation of geospatial scientists. Then lastly, I think it's time to really have everybody on board to talk about, the ethics. Now, of course, researchers like us, we have talked about this for a long time, but how about, the users, the actual users of data? How about the general public, the data vendors, the developers who write code? And then, of course, the sort of non-functioning government today, so the regulators. Now, that's my hope, of course, for a better future for us. Now, here are the references that are used in this particular, some of them in this particular talk. And this is the end of the presentation. And I look forward to Dr. Richardson's comments and the questions. I will stop sharing right now.
Thanks so much, Ningchuan and Yue, for your wonderful presentation lecture. And this is clearly a critical topic. Now let's invite Dr. Douglas Richardson to share your insights and give a discussion. And for all the participants, feel free to type your questions into the Q&A box. And Ningchuan, might be your time to start looking at the questions there. So Doug, the Zoom floor is yours.
Okay, thank you very much. I'd like to compliment Ningchuan for an excellent presentation. He was very thorough in covering many of the challenges that are posed by mobility and ethics, particularly in the geographic context. I'd like to just expand maybe build on what he just said. A key theme that Ningchuan put forth was transparency. And it is clear that transparency is a key way to approach ethical questions. I think that stepping forward with solutions, how can we have transparency and use the data and keep it. If you can have transparency up to stopping, which occurs when you have confidential data that cannot be released. And so the real Achilles heel in so much of geographic work around ethics and so forth really are the pivot around how can we want to share data and so forth. And so we want transparency, but how can you have transparency which might violate someone's privacy? So I look at a few things, few concepts. I'd like to just touch on the concept of dual use, geographic research and technology. Then a little bit about some solutions for privacy and geospatial data confidentiality. And if we have time, we'll look at some ethical and human rights issues related to intergenerational needs. In other words, what kind of planet are we going to leave for our children in the next generation and so forth. So I'll start with the idea of dual use. I had a company for about 19 years that that developed the first real-time interactive GPS GIS systems, and which are now in everybody's ubiquitous everywhere. We patented that, and we were the first to build instruments to use it for mapping and so forth. That was, a great thing. But at the time, we were mostly doing environmental transportation work. Lots of international trades and shipping and things like that. Lots of very large international contracts that we had using that. At that time, we were the only ones that had the technology. But after a point, so that went on for a long time. But pretty soon, we started getting lots of calls from the Department of Defense, from CIA, from a lot of different groups about our technology. And some of our employees said, I don't want to do this, and quit, or and the question is, it's called dual use, and it's a huge issue because technology obviously can be used for multiple purposes once it has been invented and developed. And so I think that one of the dual use things that we want to look at is just how can you use those things, and how can you shape it? So many people, I think I would say, many researchers, many students, many consumers see technology as an enemy. It's taking away things, even artificial intelligence, it will take away my brain, and all sorts of things. But I think that, we can fight, I would like to make the point that the ethical issues here are very extensive. But I think that when we look at how you can shape the technology itself. So I think one of the big challenges for geography, geoscience, and so forth, and technology in general, is how can we create technology that that empowers humankind to shape technology rather than be shaped by it. And there is a program at Harvard ran now, and it's called it's called, the mission of it is Harvard's Technology and Human Values Initiative. And their mission is to leverage the university's resources to build capacity and collaborations that empower humankind to shape technology rather than be shaped by it. And I think it's a great challenge in going forward. We're doing a lot of other work around, someone, Ningchuan mentioned, geospatial virtual data enclave, which we've been developing now for several years. And that has the value of really not, of overcoming the issue of being able to share the data or not. And for that, we have 3-4 just core capabilities. This new way of sharing data is central to science. If you can't share data, it can't be replicated. And if you can't replicate research, you don't have science. So within this system that we've been developing, the core capabilities are to share, provide access, analyze, replicate, and build on NSF research or other research involving geospatial data within the system. And we're very close to having these systems fully functional now. We made great progress. And secondly, everybody has to write data management plans, right? And you get your, Xiao has so many, he probably has reams of data management plans. But the whole idea behind data management plans is originated at NSF as a way to get the data and the results of the research out to other researchers. In other words, to share it. And but then suddenly, when in geography, confidential geospatial data began to be part of so much of our research, including a lot of health research now. Part of it, pushed by COVID-19, but more widely, all kinds of health research. So the question is is how can you share that data, because much of it is confidential. And so what we're making a solution for is a way that researchers can, within a virtual data enclave, share their data and build on it, that research, and analyze it. And when someone wants to, you could replicate it, but you can't replicate that research if you can't access the data. And so here's a sort of not point. So I think that that's it. And we're also developing geomasking and encryption methods to enable researchers to analyze and export maps, analyses, and visualizations derived from the analysis conducted within the GBDE. And that's got a huge set of rules and so forth. I don't know how many of you have had to access restricted data at various universities, but it is not an easy thing to do. And it's very time consuming. You have to develop RUDAs, restricted data, user agreements, and it's a real pain in the neck. So we're looking at doing something together with the University of Michigan to develop a very innovative researcher credential system to provide trained and trusted researchers with a durable digital identifier to safely access and use not only the GBDE, which is first being developed for, but for our repositories all around the country. So if you want to go, you need data from Cornell, or you need data from Michigan. You don't have to go and fill out all that paperwork and wait months and months at each place. You can use it. So, and then thirdly, Fourthly, we're then taking a lot of steps to build training materials, data confidentiality, ethics, and credentialing requirements for best practices and so forth. So this is coming down. We should be all of these major research infrastructures should be ready within about 18 months from now. At least most of them, and then a few more for around 24. So it's been a long-term building it. It's been very exciting. And, I think it'll be highly useful in our field. So there are a lot of other things we could talk about, but I think we have time is out. If you have questions, we could go into a lot of different kinds of ethical issues, and not only quantitative work, which we're all involved in, but also qualitative research. Still, lots of ethical issues there, resulting from interview work and so forth. And then we got to look at some special situations like where you may be doing international field work. I used to do a lot of that. And so how do you what kind of ethical behavior do you have to put in place? It's a whole new realm of disclosure of funding, disclosure of the data that would be collected, how it would be used, and so forth. And I a long time ago, I had a practice of any international work that I did, whether it was in a poor country or a wealthy country. I always made sure that all of the human subjects knew what was going on and had written agreements that they were willing to go forward on those bases. So I think that's really all we can say right now. But I gotta leave it there, and I hope this will have some of the upcoming young grad students to pick up on some of these ideas. They're very exciting and they're really needed. And thanks again, Ningchuan and Xiao.
Thank you. Yeah, so I think, let me just touch one of the things you mentioned. So I think it seems that protected data is accessible to the quote unquote right people, right? So there's a procedure to go through, but then you can get them, individual level data and those things. But it's really the concept of how can we understand the process that comes out from there, right? What are, when you produce new data, what would be, how much we should trust, right? So really the trust issue has to be there, even though we cannot see the original data source or we cannot see the original source code by any means. So there might, so maybe there is a way for us to have some standards, for example, so that we basically can build some kind of trust to the data sets and to the algorithms, so that so that we can feel more comfortable to use that for our own research.
Yeah, well, you're right, and not everyone can access it. They don't have many people don't have skills to do that. But if you're looking at it from the point of view of the scientific community, we do have ways now to test those algorithms and to test them in data that could be shared and tested and perhaps replicated or not within GBD. So that whole function can be within a virtual GBD. And if that's also because it is virtual, it can be used in other countries. It can be used around the world. And so you're not limited to having to go to like at NIH, when you want restricted data, you go to sort of cement block building with no windows, and you get searched when you go in and you just go out and so forth. So it's a big step for this concept is also the fact that it's virtual. And so
yeah,
it's a good point you just made.
So there's one question right now. So Naomi asked, have you or do you plan to connect your algorithm/model on traffic density and mobility to COVID-19 spread in the study area? So right now we're talking about the scaling up of the algorithm. Yuelin discussed in the part of the presentation. So once the algorithm can be scaled up to analyze the images automatically, then yes, then we will be able to look at the framework. Hopefully COVID-19 will be done at some point, right? So we will be able to take a look at that and see how the traffic density actually changes. And then from there, we will derive some other mobility data and information. Yuelin, do you have anything to add to that question?
Yeah, so I think our current focus is to develop the algorithm, and we also want to like connect the road traffic metrics to the to a broader range of mobility measures like OD matrix. So if we have the this approach, so if we can develop this approach, we can like develop many, I don't know, we can have some applications based on these methods. I think that's our overall plans. Yeah.
So maybe Xiaowen, should we just open up, invite everybody in, or what's the plan?
Yeah, I think we could have people raise their hands first. We'll keep the recording continue for a little while. Certainly I want to extend my many thanks to Doug for sharing your insights, and it was a wonderful discussion. So any folks, if you want to post any questions, yeah, you could raise your hand. We could activate you as a panelist. So while you might be thinking of your questions, I have a technical question for Ningchuan and Yue. So currently, if I understand correctly, in your data set, you're not enabled to identify, specific cars, from their templates. So from multiple cameras, how's the feasibility of deriving this origin and destination flows? So currently it seems to be just a density of cars on particular road segments. But much of the mobility work has been addressing flows and the trajectories. Are you looking to ways of deriving trajectory flows information, or you've done that or part of your future work?
So the short answer is yes, and Yuelin can probably have a long answer for you. But in general, yes. So once we are able to have some confidence in the traffic density estimation, then we will. So then on top of that, some kind of spatial interaction models or gravity-based spatial interaction models do give us the indication of how people tend to move from one place to another place. So with that, then you will be able to develop some optimization models to to sort of reallocate the traffic in from the links to the origins and destinations.
So the origin destination not at the individual car level, but at the traffic zone level?
Yeah, you have to aggregate.
Okay. Thanks.
I mean, you may or may not be, you know, so there are only that many cameras, so you won't be able to see every place, you know, through the camera. So aggregation seems to be the best way. You have to, you know, so you can derive the OD matrix. So you have to, you know, because you have to define the O's and the D's, right? So regions are regions. So the regions, then you will have some ways to aggregate them into different regions.
Mm-hmm. Yeah, go ahead, Doug.
Ningchuan, you wound up with one of your last set of slides talking about education and ethics. And I would offer to put you together with some people at Harvard who are doing something called embedded ethics. Mm-hmm. Embedded ethics is a program that integrates custom designed ethics modules into a range of courses across the university. This program is an expansion of something called embedded ethics CS, computer science. Successful collaboration between the faculties of philosophy and computer science at Harvard that introduces ethics curriculum into existing courses. And I think that those ideas, as we go forward, are important, is because most people, there is so much ambiguity and so much ethics that people talk about. A lot of people that talk about ethics the most often are but also I think that this kind of program you may well have in both of your universities already, but they're designed to have a package of how you can apply that for your own research, and it's a combination of, as I said, computer science, philosophy, and a couple other areas. So if anyone is interested, I could connect you with them.
Yeah. So the way I was looking at this one is really from this kind of a backward design. So we look at what we want our students to be, so that we can incorporate different techniques and different contents into the curriculum. So, but we got to set our goals right? Or you know, so when we talk about that, probably, you know, contents are less important, and then we specifically design our courses to fill up the gaps, and then we look at the contents. So definitely, I think there is a lot of advances in the computer science education that we can borrow, you know, strengths from. They have done a lot of work that, you know, we haven't even thought about. Yes.
Doug, there's a question for you from the Q&A. I'm not sure whether you're looking at the Q&A box. I could read out the question from Peter Kedron. He's curious whether the data enclave you mentioned you've been researching are open to outside researchers, and whether there's a place he or we can find the resources papers that are already available for how to access the enclave.
Yeah, we're still in the research stage right now, but we will be able to bring people in within the year. So, Peter, it would be great to work with you.
Yeah, I guess a follow-up comment there is, Peter, feel free to follow up with Doug to see how could it work together, and Peter's interest in reproducibility, replicability in general in geographical research, and how this might impact, you know, his project benefiting through, through your data enclave. Colleen, we might want to open up now for the folks still around and have everyone promoted as panelists so that they could turn on their camera to directly interact with.
That sounds good.
Yeah.
Yeah, that sounds good, Joe. And I'll stop the recording and elevate everyone to panelists.
Thanks, Colleen.